There you go. Label one interior angle, one exterior, one central. No problem. I'll do that. Okay. I'll do this. Go to this corner right here. I call that I. So in this case, there's many. You just have to identify one. Okay. Okay. Exterior angle. You grab one of the sides. Follow along for now. Okay, guys, back there. I know you're talking math probably, right? Exterior, right there. Central, you go to the center. Pick one side, right? Let's pick this one here. That is a central angle right there. Okay, that's it. The sum of interior angles. Let's figure out how many sides did you count. N is equal to 13. That's what I counted. So watch, make a check mark where you start and then just count, right? So you don't double count. So the sum of a 13-sided, please show me the formula at the very least. I would actually encourage you to go one step further, clean it up, right? And then you get 1980. 1980. 1 mark. The measure of one interior angle, you could actually just go 1980 and just divide it equally amongst the 13 angles that are there. And that would be 152.31 degrees. The more sides, guys, the more sides a polygon has, the bigger the angle is going to get, right? Because it's getting bigger and bigger to make up for all the sides, right? Calculate the measure of one exterior angle. There are 2 ways of doing that. I would recommend you know both ways, right? One would be 180 minus 152.31, which is 27.69. Or 360 divided by 13. Hey, it's the same. I did round. That's what it is, rounded. 27.69 because there's a 2, doesn't affect the 9. Okay. Calculate the measure of a central angle. It's the same as the exterior, always. And no surprises there. This only works with regular polygons, right? You can't assume that every angle is the same if it's not regular, right? Calculate the number of diagonals that can be drawn. That should be a bonus mark, right? How many diagonals can draw them, actually draw them inside that shape. But then I have to mark that, and I don't want to mark that. 13 times 10 divided by 2, that is 65 diagonals. Okay, 65 of them, not degrees. You can leave it 65, but if you put degrees, then you're in trouble. Sum of all exterior angles, 360 always. It's a pretty cool feature actually. I have my iPad. I'm gonna show you. It's pretty cool what you can do with GeoGebra. If you've ever heard of it, it's a free app. You can download it. Okay, so this page is what, 1, 2, 3, 4, 5, 6, and then there are 3 marks associated to just labeling them. So it would be 9. Let's go with 9, and then I'll add. Hold on. 9 so far, right? And then there's 1, 2, 3, 4 diagrams. So we're gonna go 9 plus 4. We're gonna make this page out of 13 for those diagrams. Yeah. Rhombus. So this is one version you could use. It should be slanted. Be specific, right? All 4 sides are the same. You can also say that the diagonals are perpendicular. You could also say that this stretch of the diagonal matches that one. This one here matches that one. So you don't have to do more than 2 things, right? But I'm just giving you all the options. The parallel sides is missing. I think it's a bit too much already, so I'm just going to leave it there. But these 2 are parallel, and so are these 2. So just use arrowheads if you want to use that property. Okay, so you get a mark for that. A kite, make it look like a kite. Okay, a bit like the bottom or the top should be longer. So you can say that the diagonals meet at a 90, and you can say that the short diagonal is cut in half. You can say that this side is the same as that side, and this side is the same as that side, right? They're congruent. What else can I say? Oh, one pair of congruent angles, right? So you could say this angle is the same as that one. But these do not cut in half. Only the top and the bottom do cut in half. That's not really a property I need you to label, but I just need you to know it when you're working with them. Parallelogram. It looks like a slanted rectangle, right? In general. So I'm going to say these two are parallel, these two are parallel. That would give you half a mark or half of the marks associated with it. And what else can we say? We can say that this side and this side would be congruent, and this side is congruent to that side. You could also say that the diagonals bisect, but they do not form a 90-degree angle. They're not perpendicular, right? So, and there one is longer than the other. So watch your markings be consistent, right? So a mark for that. Isosceles trapezoid. Hey. Yeah, sorry about being so late. Okay. Welcome anyways. These two are parallel, right? And these two are congruent. These two are the same, these two angles. So are these two. Okay. The diagonals, nothing really happens. They are the same. The diagonals are the same, but they do not bisect. So you could say that if you wanted to, right? So that would be an isosceles trapezoid. You could use numbers for the sides, like 10, 10, or whatever, but markings is probably easier. So 13 marks for this page. Right, that way you can follow at least, right? Okay, backside. There will be at least one that I remember, one backwards question. If a polygon has a sum of this many degrees, how many sides does it have? You have to show your work if you want to score full marks here. So the sum, as you know, is n minus 2 times 180. We know that this is 3420, right? So you just substitute that in, and n stays. The right side is basically untouched. Then you divide both sides by 180. 3420 divided by 180 is 19. And then you get n minus 2 on the other side. The next step would be to add 2 to both sides. Right? This cancels out then. And so you end up with 21 is equal to n. And so you figured out that this polygon must have 21 sides to fulfill that requirement. And I go over several of these on the polygons video, so if you need to refresh that, I go through it a bit slower, different colors. A pentagon has the following. Read carefully. What does it say? Exterior angles. These are all exterior angles. Determine the value of the last exterior angle. So there's 1, 2, 3, 4 angles given. A pentagon tells you that there are 5 sides, 5 interior, 5 exterior, 5 central. Okay. 5 ices. Oh, right, ice. Another thing I need you to read is this, would this be considered a regular pentagon? If every single exterior angle is different, that means that every single interior angle will be different as well. So no, it's not regular. Okay, that's another thing you need to remember. So I'm going to say this: the last exterior angle, let's call that angle A, right? So to figure out angle A, we would go 360 degrees because we know they all add up to 360. Minus 71, minus 68. Got it? That's 74. It has two exterior angles that are the same. So it seems like a simple question, but there's so much here that you need to know. Remember, I'm going to try to do this, right? I'm not really good at, but this is probably some kind of weird looking 1, 2, 3, 4, 5. Some kind of weird looking pentagon. And so they give us all of these angles here, right? They gave us all the exterior angles, and so we're just working with those, and we know that they always add up to 360. Okay. Consider the following regular polygon. What's the value of angle C here? This one. I'm glad you asked, right? 360 divided by how many sides? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. Okay, so divided by 15. Let me just get to it. That is 24 degrees exactly, right? Perfect. Could be a decimal, just go with it. Calculate side X, which is this one here. So we have 50 and 50. We have 24 and here. We just figured that central angle. So that's cosine law, sorry. X squared is equal to 50 squared plus 50 squared. Lots of 50s here, right? Show me that. Show me the next step when you type all of that in. That's 432, 27, 27. That keeps going. That's 20.79 feet for that. One side of that 15-sided polygon. That's yesterday's lesson, by the way. How to do this stuff right here. So we started with a central angle, SAS, right? And then we use cosine law to get the rest. What's the perimeter of this polygon? Well, it's just 15 times 20.79 feet. Area is optional, right? I told you that. Area, it actually might be a bonus. Okay, so if you know how to do areas, you can possibly score some bonus marks. Okay, next, calculate the measure of MN, right? So this angle here, if this is 90, this is 45, then this is 45 here. So angle M is 45. N, that's 44, right? Because if this is a 90, 46, that must be 44. Okay, so we've got that figured out, 1 mark for each. No problem. And now classifying time. ABD, so ABD, it's this one here. That would be a right. And this is an isosceles because you've got two angles that are 45. So this is an isosceles triangle. ABC, so ABC is the big one here. If this is 44, the whole thing here is 89, right? So you gotta, I'm gonna do that to you, right? Like it's gonna be so close, right? So that's 89. That is an acute Scalene. How do you know it's a scalene? All angles are different, right? 45, 46, 89. You know all sides. So if you are able to get all angles, it's the easiest one to classify, actually. Okay. BDC is this one. BDC is this triangle. So that one is right for sure. Some of you went right acute on the other AC. Like, you can't say that. That's not working. Right. That's scalene. Because 90, 46, 44, right? Within that triangle, all angles are different. So that's sorry. Sketch a kite. Oh, did I make you label a kite already before? 3 properties though. So you get another go at it. Why would you do that? 1, 2, 3. That's 3 properties. Say what? Right? You could keep going. Don't say parallel. There's nothing parallel for kites. Okay. So some students I've seen on tests, they say, hey, this one is parallel to that one. No, they never meet, right? Obviously, they're meeting right here. Their parallel lines never meet. 3 marks for that one. Wow. Inflation. Okay. So let's see. 3 and 3, that's 6. Plus 2, that's 8, 9, 11, 12. 12 and 2 is 14, 16 for the back. It's a lot of marks. 16. 16 and 13, 29. Okay. So get rid of that 25, just make it out of 29. I want to give this one back to you today. So